the way some of you were answering that question is not proper. My question was, distinguish between a strong acid and a weak acid. Eh? Glory, I saw you coming. Can you tell us the answer? What is the difference between a strong acid and a weak acid? Please, we are busy. These people who are sending messages of good morning, I don't like them. I'm asking a question, I want answers. Don't send those messages of good morning. Karen, please. Karen, are you there? Karen, are you there? Okay, Glory, you are now on. Glory? Glory? What's wrong with these girls? Glory and Karen, that question is yours. Karen, can you tell us what is the difference between a weak acid and a strong acid? You can see that we have a problem. Okay, someone tell us from the group, any one person. Rebecca. Okay, Amera.
A strong acid is an acid that ionizes completely into ions when dissolved in water, while a weak acid is an acid that doesn't completely ionize in water.
Very good. That's what I wanted. Whenever you are talking about ionization of an acid, you must talk about water. An acid will not ionize if there is no water. So an acid will only ionize in presence of what? Water. So we said strength of an acid refers to the ease with which an acid ionizes to produce hydrogen ions. And here we are defining a strong acid. We are saying is an acid that dissociates or ionizes completely into ions when dissolved in water. So in bracket we are putting a simple definition. It is an acid that ionizes completely in water. That is enough. It is an acid that ionizes completely in water. And the word to ionize means to form ions. And examples of strong acids we saw, there is sulfuric acid, there is hydrochloric acid, and I told you there is one other acid which is not included here, and it is strong. Who can tell us that acid among the strong acids?
Nitric acid.
Yes?
Nitric acid.
Wonderful. Thank you. That is nitric acid. So nitric acid is also a strong acid. Then weak acids, we are saying weak acids, they do not ionize completely. They do not ionize completely, or we can just say they ionize partially. We can say they ionize partially. So weak acids, we are saying a weak acid is an acid that does not ionize completely in water. Okay? And examples, we have carbonic acid, which ionizes to form hydrogen ions and carbonate ions. Then we also have ethanoic acid. So I'm reviewing this work so that you people can understand it very well. I told you to summarize the notes here. Not to summarize. Whatever I tell you here is important. Like all these notes on acids and bases, you should write them. I hope all of you have a copy of the notes because I sent to you. Uses of acids. It is used in car batteries, that one you remember. Sulfuric acid is used in manufacture of paints and detergents. Then we have hydrochloric acid, which is in the stomach, and it helps in digestion. Bases and alkalis, we said a base is a substance which reacts with an acid to form a salt and water only. That is a base. And the examples which we gave majorly were examples of these oxides. When you look at these oxides, all of them are oxides of metals. And when we were in senior 1, we categorized the oxides. We said we have acidic oxides and we said we have acidic oxides and basic oxides. We said acidic oxides are oxides of nonmetals and which when dissolved in water produce acidic solutions, whereas basic oxides, these are oxides of metals which when dissolved in water they produce alkaline solutions. And examples, we have copper 2 oxide, we have magnesium oxide, we have potassium hydroxide. All those are what? All those are basic oxides. So bases that are soluble in water are called alkalis. So we said an alkali is a base that dissolves in water to produce hydrogen ions, not produce hydroxide ions as the only negatively charged what? Ions. So someone can say an alkali is a soluble base. That is correct. So an alkali is a base that dissolves in water to produce hydroxide ions as the only negatively charged ions. And examples, they are there, we gave them. We have potassium hydroxide, sodium hydroxide, ammonium hydroxide, etc. So I think we stopped having looked at these reactions. So we are now continuing and looking at strength of bases and alkalis. What is a strong alkali? If we have been saying that strong acids ionize completely in water to form hydrogen ions. Then we shall also say the same thing, that strong alkali is the one that ionizes completely in aqueous solution. Strong alkali is the one that ionizes completely in aqueous solution. Strong alkali is the one that ionizes completely. So when you are talking about a strong acid or a strong base, that word must be there. Ionize, and to ionize means to form ions. To ionize means a substance dissociates to form its respective ions. So if it forms the ions completely, if it ionizes completely, that one is strong. And if it ionizes partially, then that one is weak. Okay, so we have strong alkalis. We have sodium hydroxide. Then we also have potassium hydroxide. When these ones ionize, they form their respective ions. Sodium ionizes to form sodium ions, and potassium hydroxide ionizes to form potassium ions. Now, I want to give you some examples. Then, a weak alkali does not ionize completely in aqueous solution. And the only example which we have is ammonium hydroxide. Ammonium hydroxide is a weak base. So strong base or strong alkali ionizes completely in water, and the examples are sodium hydroxide is a strong alkali. Potassium hydroxide is also a strong alkali. Yes, those are the examples. Now, weak alkali or weak base, we are saying we have ammonium hydroxide. We have ammonium what? Hydroxide. Take note of that. What is neutralization? Now, in math, let me begin like this. In math, if you have +1 and you add -1, what is the answer? The answer is 0. But you also say at the same time that 0 has no charge, don't you? You say that 0 is neutral. So when we are talking about neutralization in terms of acid and base, neutralization, you know, I told you the most reactive part of an acid is the hydrogen ion. Just a minute, please. Okay, I'm back. I was telling you that the most reactive part of the acid is the hydrogen ion. So an acid is defined by a hydrogen ion. Okay? An acid, for a substance to be called an acid, when it is dissolved in water, it produces a hydrogen ion. And the hydrogen ion is positively charged. Okay? So in your book there, write hydrogen ion, write hydrogen, then you put a positive charge on the top right. I think you know what I'm talking about. Now, a base or an alkali, we have defined it as a substance that dissolves in water to form hydroxide ion as the only negatively charged ion. So write hydrogen ion, and below it you say from acid plus hydroxide ion. Hydroxide ion has one negative charge, and below it we say from alkali, and the product, those two will form water. Now the water that is formed does not have a charge. The water that is formed does not have what? Charge. Do you understand what I'm saying? So that is neutralization. A positive hydrogen ion from the acid has been neutralized by a negatively charged hydroxide ion from the alkali to form water which does not have a charge. So that is what we call a neutralization reaction. We are saying this is a reaction between an acid and a base to produce salt and water only. I repeat, someone should note it down. Someone who is serious should note this down, that neutralization is the reaction between an acid and base to produce salt and water only. These neutralization reactions are going to be very important in practicals. The time when you went home, actually for us at school, we start practicals in second term, and you are aware. So if you were at school, you'd have already started practicals. And in practicals, it is where these neutralization reactions are very common, whereby you react an acid with a what? A base. So neutralization is the reaction between an acid and a base to produce a salt and water only. The resulting solution is neutral, that is neither acidic nor alkaline. That's why I told you you form water which is neutral. Yeah, you know water is a neutral oxide. It is neither acidic nor alkaline. Examples of neutralization reactions. Here I have sodium hydroxide plus hydrochloric acid, and the product is sodium chloride plus water. So the base is sodium hydroxide, and for the reaction to be neutralization, listen to me, then you should use a strong acid with a strong base. You cannot neutralize a strong acid with a weak base, and you cannot neutralize a weak base, a strong base with a weak acid. So all of them must be strong. Sodium hydroxide is a strong base. Hydrochloric acid is a strong acid. The product is sodium chloride plus water. So when you are doing this reaction, always remember that sodium will come for chlorine, and then hydrogen will come for hydroxide, and you form, when sodium comes for chlorine, you form sodium chloride plus water. Then sulfuric acid plus potassium hydroxide, the product is potassium sulfate plus water. Sulfuric acid is a strong acid, and potassium hydroxide is a weak base. Now, there is an important statement here. Essentially, this is what I was telling you, that I told you to write down. Essentially, neutralization takes place when a hydroxide ion, that is the hydroxide ion I was telling you, reacts with a hydrogen ion to form water molecule. The hydroxide ion comes from an alkali. Remember, we defined an alkali as uh, a substance or as a base which dissolves in water to produce hydroxide ion as the only negatively charged ion. Eh? Eh, So the hydroxide, this is the equation, this is what I was telling you to write. Hydroxide ion is from a base and the hydrogen ion is from the acid. And the product is what? Is water. Now, there are situations where you form both, where you form both a weak acid and a strong acid. For example, write this. I want you to write the formula of ammonium chloride, which is NH4Cl. Write the formula of ammonium chloride, which is NH4Cl plus water. Ammonium chloride plus water. The product in that case is ammonium hydroxide, which is NH4OH, ammonium hydroxide plus hydrochloric acid, NH4OH plus HCl. Now, the product that you have formed, you realize that you have hydrochloric acid, which is a strong acid. You have ammonium hydroxide, which is a weak base. Are you listening to me, you people? So who can tell me whether the resultant solution, that product, is acidic or alkaline? The resultant solution that has been formed, which is a mixture of ammonium hydroxide and hydrochloric acid. Someone tell me, is that resultant solution acidic or alkaline? Come on, save time. That resultant solution is going to be acidic. Get me, you people? That resultant solution is going to be acidic. Reason being, hydrochloric acid that has been formed is a strong acid. It ionizes completely to form hydrogen ions, whereas ammonium hydroxide that has been formed is a weak base. So it ionizes partially to form hydroxide ions. So at the end of it all, you realize that the number of hydrogen ions from hydrochloric acid, which ionizes completely, the number of hydrogen ions are going to be more than the number of hydroxide ions, because the base does not ionize completely since it is weak. So that's why the resultant solution will be what? Acidic, because it will contain more hydrogen ions than hydroxide ions, because the acid which is produced, hydrochloric acid, is a strong acid which ionizes completely, form more hydrogen ions than the hydroxide ions of the base, which is weak. Indicators. An acid-base indicator is a substance that shows different colors. An acid-base indicator is a substance that shows different colors in acidic and alkaline solutions. So indicators are usually used to establish whether the solutions are acidic or alkaline or neutral. And the color change of the indicator depends on the strength of the acid. Some examples of indicators that are commonly used, we have litmus paper, that one we already know. If the solution is acidic, the blue litmus paper will turn to red. We have methyl orange indicator. We shall be using this in practicals. The rest I'm not going to look at them, but I want you to write. We shall be looking at methyl orange indicator. This one, methyl orange indicator, and phenolphthalein indicator. For the litmus paper, you already know. So those are some of the indicators that we shall be using in our practicals. Now, what is a universal indicator? A universal indicator is a mixture of simple indicators that undergo color change. Yes, and a universal indicator also shows the extent of acidity and alkalinity. So let us look at the indicators, how they behave. Litmus paper, you know it. Color in acidic solution is red. Color in neutral solution is purple, and color in alkaline solution it is blue. That's why when you dip a blue litmus paper in an acid, it turns to red. And when you dip a red litmus paper in an alkaline solution, it also turns to blue. Methyl orange, its color is pink in acidic medium. Then neutral, it is yellow. No, neutral is orange, and alkaline, it is yellow. Phenolphthalein in acidic medium, it is colorless, neutral colorless, and in alkaline medium, it is pink. Now, pH scale, I think you remember it. It shows the strength of, it shows the acid and basic strength of a substance. You should be remembering this pH scale. When a substance is neutral, its pH is 7. That one you remember. Yeah? And when the pH is below 7, that solution is acidic. And when the pH is above 7, the solution is what? The solution is an alkali or a base. However, the lower the pH, the lower the pH, then the stronger the acid. And the higher the pH, then the stronger the alkali. So that is it that you need to know. All these of logarithm and what, we shall do them in senior 5. They are not your level. For you, you only need to know that when the pH is less than 7, the solution is acidic. And when the pH is greater than 7, the solution is alkaline. And when the pH is equal to 7, then that solution is neutral. Okay, that solution is neutral. Any question about what we have talked about? Any question? These days you are not active. I'm not happy. I ask you questions you don't want to answer.